Okay, so for this video I'm just going to work some of the extra sample problems. If you haven't done so at this time, go ahead and work them and then come back and watch the solutions. This problem requires a little bit of a different technique because you can see that 3 and 2, it's going to be really basically impossible to create the same exponential base for those. So this is where we're going to use our one-to-one property, or where we can actually make both sides have the same log with the same base. So we're kind of reversing that one-to-one property a little bit. Okay, so you can see we've got a little bit of a different scenario going on here. Now what I'm going to kind of do with this is, and this may look a little strange to you at first, I'm going to actually distribute the log to both of these parts. What I did in this step is I took my log base 10 of 3 and I added that to both sides. So basically -1 times that log just basically gives me negative log base 10 of 3. So I added that to both sides and ended up on the right side. Simultaneously, I subtracted the x times log base 10 of 2 to the other side. Now, what we've got here is we've got a situation where they both have a common x. So if you recall, this is almost kind of like grouping. We've got two terms here that have a common term of x, which I'm going to factor out. So when I factor out that x, I'm actually left with log base 10 of 3 minus log base 10 of 2. So you can see that this requires some similar skills that you've used in other algebraic type of equations, but it looks a little different with a whole bunch of logs spread out throughout the entire equation. Now I have log properties that I can deal with inside the parentheses, and I'll go ahead and do that. Now from this part right here, I just divided the expression inside the parentheses from both sides. What I'm basically going to do from here is just simply plug it into my calculator and come up with an approximate decimal value. Alright, and I'll go ahead and stop right there. In the next video, we'll work on solving logarithms with different bases, and this presents a different type of challenge. Okay, we've saved the best for last. This is where solving logarithmic equations starts to get a little tricky. What we're looking at now is, in the past we've always had logarithms that have had the same base, and it's been easy to just use simple properties to eliminate the logarithms and solve the simple algebraic equation. Now what we've got going on is we're going to actually have logarithms with different bases. Now the example that I've got here on the notes is just another way of looking at a simple rewrite problem that we've done in the past, and showing you how we can actually make that problem have the same base. And so if we take this part of the example right here, we notice that we have log base 1.035. Well, what we're trying to introduce to you here is what we call the change of base formula. I can actually change that to have a base 10, and what I'll do is I'll take the 5 and I'll bring it to the top part, and I'll take the 1.03 and bring it down to the bottom part. And so what we've done here is we've used what's called a change of base formula, and this is actually going to come out to be the same value of 54.4. And of course that's what we've got going on down here. Obviously base 10 is not written, it's a common logarithm and it's kind of understood. So this is an example of how you can create the change of base formula by using different properties. Now one of the things that you need to understand about change of base formula, if you look at this concept box, notice it doesn't say that it has to be log base 10. It can be any log base as long as the log bases are the same, and you can use this change of base formula. Now this is going to come in real handy when we're solving different equations of logarithms that have different bases. And if we take a look at this first example here, you can see we've got log base 3 x minus 6 equals log base 9 of x. And so if we move the log base 9 over to the left side, that would be a little problematic because we wouldn't be able to use log properties because of the different bases. And so what we're going to do here is we want to take the smaller base, log base 3, and we want to use that log base as our change of base property. So right here we've used log base 3 to change the base of log base 9, and from there we have some workable parts. Now what we're hoping is for this scenario to happen pretty regularly, where we have a logarithm that actually evaluates to a simple number, and then we can go from there. And you can follow along in this example. You can see it gets a little bit complex, and then of course we finish with a quadratic and no less an extraneous solution. And so you can see that a logarithm problem like this can be very involved when it has different bases, and it can go many different routes. And so you're going to have to be really on your game and thinking very well to answer these equations. So go ahead and do the best you can. Sample problem number 8. All the tools that you've learned in this unit so far could come into play. So go ahead and try sample problem number 8 and then come back and watch the solution. You can see that the smallest log that I have here is log base 2, and so I'm going to use log base 2, which is simply a multiple of 4 and 16. That's always very convenient. So I'm going to use log base 2 for my change of base formulas. Okay, there you go. And basically, if you followed along as I wrote out each of the steps, you can see that there's not anything algebraically different than what you've learned between Algebra 1 and Algebra 2. It's just a lot of different strategies, a lot of different algebraic properties, all being used on logarithms to come out with a very clean answer here. Alright, so be prepared in class to work some challenging problems like that.